Today we will be discussing about another amazing concept in deep learning, and that concept is what we call as transfer learning. So what is the meaning of transfer learning? First of all, let's try to understand. If you will go towards the standard definition, which you can find on Wikipedia or any of the references. So if I will just try to open in front of you and we can go to the Wikipedia page, if we will be able to find out. Yep. So this is a very famous definition which you will be able to see. Let me just copy it and then paste it over Scribble ink. Listen this very carefully, and then I will try to correlate this concept with the real-time example so that it will be easily, you will be easily able to get what I'm trying to convey over here. So what is this transfer learning technique is all about? It says that it's a technique in machine learning in ML in which knowledge gained from a task is somehow reused in order to boost the performance on a related task. So, transfer learning. Transfer means that, let's say, you have gained some knowledge with respect to a given specific task, and now I have assigned you some different task, and you are trying to build the intuition to solve that different task based on what knowledge you have gained on the previous task. For example, with respect to the modeling part, for image classification, knowledge gained while learning to recognize car would be applied when trying to recognize trucks. So let's say you have built a model and the model is specifically being designed to recognize a car. But now if let's say I have shared with you or I have shared with the model an image of truck, and I really want that specific model will be able to recognize that it's a truck. So somehow I can use that same model, which is efficient to recognize the car, and maybe I can on top of that supply a lot of knowledge with respect to the recognizing of truck part. But rather than training the model from scratch to recognize the truck, what I am doing is I am trying to uh, apply the concept of transfer learning, where whatever knowledge my model has gained to recognize a truck, that model is using similar knowledge to somehow build a intuition towards recognizing a truck as well. So this topic is related to psychological literature on transfer of learning, although practical ties between the two fields are limited. Reusing or transferring the information from previously learned tasks to new tasks has the potential to significantly improve the learning efficiency. This specific concept of transfer learning in deep learning, when it came for the very first time, it was a breakthrough because after this specific concept, researchers felt that the time required to train the model from scratch that have been instantly reduced, and at the same time the computational part, the computational cost, that is also have been reduced significantly. Now this specific concept came from real time scenario only. uh, I hope you guys know how to drive a scooty, right? So, as far as I can recall my time, so it was very easy for me to understand that how can I drive a scooty, because I already knew at that point of time how can I, drive a bicycle. So somehow it's kind of a balance only, although the vehicles are different, although they have different concept internally to drive, but you will be able to understand that the concept required to drive a bicycle is balancing. That's the major thing which I can directly apply to drive a scooty as well. I hope you can correlate, yes or no. Although they are different, but somehow what we are doing, or what the person who is or already aware that how can I drive a bicycle, they are directly using that concept, so somehow they're transferring the knowledge. On top of it, they're learning some new features of scooty. Same thing our models are doing. So they are learning something. We are trying to use those models. And on top of it, whatever task we want to apply, we are trying to feed them that specific data, and they are doing it in a very smart manner. That's the whole point of transfer learning. That's the whole crux of transfer learning. Is this clear to everyone? Can I get some confirmation what I'm trying to convey over here? Now, this concept of transfer learning have been split into two parts. In deep learning, we can apply this concept of transfer learning in two ways. First way is what we call as feature extraction. First way is what we call as feature extraction. And the second way is what we call as fine tuning. But before talking about both of the ways and how does they work, we should talk about the meaning of pre-trained models, which we will use in the transfer learning part. And on top of those models, we will either go with the feature extraction or fine tuning. So what is the meaning of pre-trained models on which we will apply the transfer learning concept? Pre-trained models. Pre means already. So they are already trained. Now, these models are already trained on a very huge amount of data. So in the real-time use cases, you will be able to see that we have a list of a lot many pre-trained models designed for a specific task. You say image classification, we have pre-trained models. You say, I really want to do object detection, we have pre-trained models. I want to do text summarization, we have pre-trained models. I want to do text generation, we have pre-trained models. So whatever be the specific task you want to perform in any given use case, corresponding to that specific task, we have corresponding pre-trained models available with us. Means with respect to that specific task, these models are already being trained on a very, very huge amount of data. So what we will do, we always apply this concept of transfer learning on top of these pre-trained models. Okay? For example, in the last session, we have talked about VGG16. This is also a pre-trained model. That is why I told you that we can directly, instead of building this model from scratch, use its weights from ImageNet, and on top of it, we can apply our knowledge with respect to the dataset that we are dealing with for the classification task. Now, on which specific dataset this specific model have been pre-trained? Anyone, any answer? On which specific dataset this specific model have been pre-trained? That's my question. Exactly. So for this, we already know that it is being already trained on ImageNet based data. And yesterday also I have showcased you that directly fetching few lines of code from keras.application, we can call this model and we can directly use the pre-trained weights that we will be having in the VGG16, and on top of it we can apply our own data set that we will be having for the classification task per se. So this specific model is specifically pre-trained model for image classification task. Yes or no? For image classification task. Similarly, we have lot many pre-trained models. So if you will try to go ahead and check again, TensorFlow pre-trained models. And if we will go inside this, so you will be able to see this documentation. This is a unintentionally I have opened up, but this is very important. I will also share with you. Today, what we are discussing is actually this specific concept of transfer learning, which you can learn from here as well. So in a tutorial, you will learn how to classify image of cat and dog. This is what we will do today as well, as our implementation, by using the transfer learning from a pre-trained network. Pre-trained model is a saved network that was previously trained on large dataset, typically on a large scale image classification task. That is the standard definition, which I have already explained you in a layman way. But I think the context is what exactly similar with respect to what I have explained. That's the standard definition of pre-trained model. So it's already saved model that was trained on a very huge amount of data on a large scale image classification task. For example, ImageNet was one of them, right? You will either use the pre-trained model or as is, or use transfer learning to customize this model for a given task. So today what we will do is we will try to customize the model for our desired task. And I will showcase you practically implementation wise, how can we do it to classify cat versus dog only. Definitely, you can classify. If you will learn how can we do the task for cat versus dog, then it's just that you just need the data set and same code which I will share with you. You can apply the same pipeline to do whatever task you want to do, right? The intuition behind transfer learning for image classification is that if a model is trained on a large and general enough data, this model will be effectively serve as generic model of the visual world. You can then take advantage of these feature maps without having to start from a scratch by training a large model. So I think this is what I already have discussed. Two ways I already have talked about, which we will discuss later on. Feature extraction, today we will see what is that, and fine tuning, that is also we will see today what is the concept behind fine tuning. But anyhow, I don't want to share this thing. I just want to open the yesterday's link. Let me just open that. And this was the link, right, which we have seen yesterday. So all of these are the uh, I would say pre-trained models, which we will be having in the Keras. So here you can see, just like the way we have talked about LXNet and VGGNet, we have different architectures like Exception, EfficientNet, VGG16, ResNet, MobileNet, Inception V3, Inception ResNet V2. Now, I think yesterday's session, I have given you one task as well, that let's explore, let's say, the ResNet architecture and the research paper if you really want to go through. And you will be able to see maybe in any of the architecture that how basically this specific architecture will work. Again, here you will be able to see we have a convolutional layers available with us and how we will be able to get the final output size in the ResNet specific task. Have you guys gone through it? The architecture of ResNet and how it will be able to give us the final output image, which I have given you as a task in the yesterday's class. Can I get any confirmation? Either say yes or no. I don't think we do have any other answer. No. What about others? What about others? Why? What you will do for recordings? You were there in the live class, right? You understood how VGGNet will work. This is really bad. Not expecting this from this class. And most probably, I won't be even available to take further sessions in April. Some other mentor will take, most probably. I might be available on weekends where I will meet you guys again. But now few of the next sessions will taken by some other mentor. So this is really bad. If I'm giving you any task after you guys have listened my 2 hours of live session, so I'm expecting you to do that specific task. No excuses for that, that recordings are not available or any other thing. You always have the open source references available with you. If the resources like recordings, they are not providing on the time, right? We always have the open source data available. And even I am sharing the resources just at the end of the session instantly to you, so that at any point of time, if you want to refer my notes and if you want to refer my code files, you can directly refer that. So just after this class will get over, whenever we will meet next, it will maybe after a week, when we will meet, I will ask the same question to you. And by that time, I am hoping that you will be having the recordings as well and everything. The time also you will be having. Please try to work ahead and take your time to get the understanding of ResNet. And don't ask the other mentor also to teach you this specific concept, because already I have taught you in a lot more detail the other networks, and I have given you this as a task. So we will discuss whenever I'll come back. You can discuss with that other mentor the new topics. Maybe you can start with RCNN and YOLO with that specific mentor in your next class. Then there are other topics that are still pending. So maybe I will also connect with that mentor or the team from where they have to start. But don't discuss with them the same topics which I already have covered up, because in that case you are just wasting your own time, not other person's time. Always try to understand these 2 hours are very crucial time for you as well, and for a mentor as well. Maybe that mentor might not be aware about what you have covered up already. And even if you will say that, hey, just cover up the previous topics, they will cover up, they don't have any issue. But in that case you won't be able to learn something new, right? So start with a new topic. RCNN is the next topic that you have as per the curriculum which I have. I told the team to change the today's uh, meeting headline also, but they have not changed it. But we are discussing about transfer learning and the different CNN architectures. In the next class, they should discuss about RCNN. So you can just let them know that till the architectural part, we have a knowledge. You can start discussing about RCNN, ResNet, and the other architectures that we will be having. This is exactly same with respect to what we have covered up. The only difference is between the count of correlational layers and the count of filters at every specific part, which is not that much difficult to understand for you now, because we already have discussed in a lot more detail. So it would be great that after this in an architecture, you should start something new to discuss with your new mentor. I hope it makes sense and it gives you clarity that what you're supposed to ask from them or expect from them, right? I will also discuss from my end. That's not an issue. But I'm just sharing you my thoughts, because in the last uh, part, when I was not available to take the class, that instance I remember, where you have not covered up some anything new. That actually disheartened me at that point of time, that already one class went and nothing new they have covered up. Okay? So that is something which I really want to share with you prior. Now, let's move ahead and let's try to further work upon this specific part of transfer learning. So, what we will do today is, if you remember, yesterday we have finished our discussion of VGG 16. Let me take this architecture again. I hope you can recall this. Yes or no? Do you remember? What happened? And we will do one project with the help of this to understand in depth towards how the transfer learning concept will work in the deep learning part. Now, again, I am taking this as a demonstration, this specific architecture. You can apply similar concept in any of the architecture, LXNet, ResNet, any of the architecture. Just try to understand the concept which I'm trying to share over here. After that, you can change the model name. You can change the data set at your end. You can apply the same knowledge towards any specific data which you will be working with. You just have to change the address or the path of the data set. You just have to call the function name. For example, today maybe I'm calling VGG16. If you want to use ResNet, just in that code part, you just have to apply ResNet 50. Everything will work smoothly. Why I'm using this specific architecture? Because I have already spent a lot of time discussing this specific architecture. And currently, I am expecting that you already know about this at least. ResNet, if you guys told me that, hey, we have covered up, then maybe I will work on that specific part today. But if not, I think this is a good specific architecture where we can discuss, because we already have internal knowledge about this specific architecture. Can I assume everyone knows about this architecture and how it works? Yes, perfect. Now, the very first technique which we have talked about, which we need to talk about, is feature extraction in transfer learning. What is the meaning of feature extraction? For example, let's say we all know that this specific architecture is being trained on ImageNet data. And if you will be able to explore this specific data set, how many of you at your end explore about this data set, which we are discussing from now past few days? This is, they have stopped. So let me check it further. So if you will be able to see its complete detailing part, it's a large visual database designed for use in visual object recognition software research. More than 14 million images have been hand annotated by the project to indicate what objects are pictured. And in at least 1 million of the images, bounding boxes are also provided. So basically, if you will be able to observe over here that with respect to this specific data set, a bigger research team uh, was initially being set. And the problem in deep learning specific stuff is that whatever be the project work you will do in deep learning, what is the problem of training the model from scratch when we will talk about deep learning domain? What is the problem which initially, before these pre-trained models came, what was the problem which researchers usually faced to train the model from scratch, specifically in deep learning domain? And how this database like ImageNet become a boom for them? So first problem was not large coding part. Coding though anyhow, because we do have a great developers uh, available, the smart minds are there. So coding is not an issue at any point of time. People really know how to code, at least in India, outside India. There are so many research labs available. And the the people who are working inside that, they are all, I would say great minded people, right? Even the research labs that we have in IITs, IIC Bangalore, outside India, MITs, people are really great in terms of writing the code. Coding, writing is never an issue. The problem to train the model from scratch is, the very first problem was data hungry. What is the meaning of that? We don't have the labeled data available with us. We don't have the labeled data available with us. So If, let's say, anyone wants to train the model from scratch, let's say they're working on any specific problem of, let's say, cancer detection. Now, for detecting a cell of cancer, if, let's say, I'm working in the domain of data science, I'm not sure which specific cell belongs to cancerous cell. And it's not me who can label it. And I don't have enough label data. For that, I really need doctors to label them in an authentic manner so that I can train my model. I hope you're getting a sense of it, what I'm trying to convey over here. So we need at that point of time a manual laborers. And manual laborers, when I'm saying that to those people who are having a great domain knowledge with respect to whatever task we are doing. If we're working with a business specific problem, we need a great business leaders to label the data. If you're working in healthcare domain, we need great doctors and so on. Are you getting my point? That was the very first issue which researchers faced at the initial time. Second issue was that when they are training any specific model from scratch, so they definitely require a lot of resources, a lot of time, as well as resources. The problem was the money. So, the huge amount of resources in terms of GPU configured part and the time, which we don't have, right? That is the issue to train the model from scratch. And that is where this concept of pre trained models was the motivation initially. That we will just spend one time a lot of resources, one time a lot of time, and then maybe we will be having those models available with us, which we can use it for our task as well, right? And that is where this very first task of feature extraction comes into picture, which says that, let's say, I want to do a task of categorizing versus maybe cat versus dog. And let's suppose the ImageNet data is already being trained on animals. So this ImageNet data is maybe already having an expertise. What is cat? What is dog? So what I will do is I will try to use the pre-trained model of VGG16, which contains the weights of ImageNet data. What I will do is I will try to fix those specific weights on the very first part, which is what we called as convolutional layer. So I won't change anything. This is what we called in deep learning words, freeze. We are freezing the weights. So we are not doing anything specifically in the convolutional part of VGG16. We are fixing it. What we are doing is we are trying, as per our own data, which we will be having of cat and dog, we will try to train this specific portion of neural network, or I would say fully connected layers. Fully connected layers. So in feature extraction, we will freeze the main convolutional part of any specific architecture and only try to work on training the fully connected layer as per our own specific data. So what we are doing, the point where we are freezing the weights is what the point where we are transferring the learning to the dataset that we will be having. Is that clear to everyone what I'm trying to convey over here? Any doubt anyone is having till this point of time? Ask me if you have any questions. Okay. So we are good with in terms of conceptual understanding what is feature extraction. Then what is fine tuning? For example, let's say your ImageNet data is trained on maybe animals, maybe different viewpoints. But let's assume that the problem that you are solving now is completely different problem, and the data set which we have in a pre-trained model is somehow different. What I'm trying to convey over here. Let's assume there exists a problem where you want to work on a classification task, which is to classify that whether it's a phone, whether it's a, let's say, Android phone versus whether it's a iPhone, Apple phone. Okay? Now, let's assume that ImageNet based data, which is a pre-trained model which you're using, which is G16, ImageNet based data has not trained on this specific class. So that is an issue, right? So in that case, somehow this specific data set won't be able to help me to understand that whether it belongs to class 0, which is Android phone, or class 1, which is iPhone. In that case, in that specific kind of concepts, a concept of fine tuning comes into picture. What is the meaning of fine tuning? It says that now I will not freeze the entire convolution layer. Maybe I will freeze the few starting components of the convolution layer, maybe till the starting 4 layers. I will freeze this much. But after that, I will try to use in the convolution layer and then in fully connected layer my own data set, so that it will be able to classify me properly whether it's class 0 or class 1, whether it's an Android phone versus iPhone. So in this specific case of fine tuning, our class is entirely different. Then you can ask me a question that, Priya, why in that case we're using the initial 4 layers of ImageNet? Because anyhow it's of no use. You can't say it. Because in ImageNet, somehow we have the different classes which helps to get that edges pretty well, which helps to get that maybe filters which we will be having in the ImageNet data. Means somehow we cannot say that the knowledge that the pre-trained model have, it's not of any use if we have a different classes. It might be useful, but entire usage is not there. So we can take few of the initial layers, and then after that we can fine tune our data on top of it to get the desirable result. Is this clear to everyone? Any doubt till so far? Anyone? So what is the difference between fine tuning versus feature extraction? If someone will ask from you, what will you answer? Yes. If someone will ask you the difference between fine tuning versus feature extraction, it is one of the common question asked in interviews. So what will be your answer? For learning the shapes and the edges, we use some of the, yes, correct. In fine tuning, for initial learning of edges, shapes, we, what we will do, we will use the pre-trained model. We use the pre-trained model, but allow some layers or some blocks or some layers to update at the time of training. For example, in this specific case, I'm saying that I'm allowing this last block in my fine tuning to train and update the weights. So in this case, I'm just freezing the initial few layers, allowing few of the ending layers to train so that it will be able to give us the better results. Yes. Now, if anyone will ask you the difference, can you just let me know? What have you understood? In a feature extractor, whole model till dense layer, fine, freeze only required part. Yes, that's the actual understanding which you should gain till so far with respect to what I'm trying to convey over here. When we talk about feature extraction part, we are using a entire pre-trained, we are using an entire pre-trained model as a fixed feature extractor, which will be able to give us the features without any updation of weights, without updating the weights. So here we are freezing the weights of entire convolutional network, right? So we will pass that new data to the final classification layer of the pre-trained model, which is the dense layer. In full fine tuning, we will take the initial few blocks, but the further blocks plus the dense layer, entire weights will be changed. That's the whole point. Is this clear? Is this fine for everyone? Shall we move ahead and discuss? If the concept is clear, then maybe we can move ahead and discuss the implementation part for the same. Today, it would be difficult for me to like do the training with you guys on the go in the live class because dataset is quite huge, which we will take. In deep learning, doing the implementation side by side is easy when we will be having a small data. As soon as you will be working with a bigger amount of data, so if I will do it in a live class, it might take few hours to train the model itself, and our session will be over in that case. So for that specific part, I will try to make you understand what we are doing. It's your responsibility once the session will get over because at your home you have a lot of time, right? And you can just put your system on, keep doing your model, get trained, and then maybe you can check that how the results are coming up, whether the results are similar to what I'm getting or that is different. Okay? So we will try to work upon it. And for that, first of all, what data we will be working with, let's try to understand. So this is the file that we are picking up today. I'm sharing with you in the chat window. Do one thing, just sign in your Kaggle account. Maybe with your personal ID, you can easily sign in. After that, there is an option of download. Download this data. You will be able to get a zip file, archive file, just like the way I'm getting. This is a quite big file. That's why you will get a zip file over here. You can download it. Just do it. And after that, just unzip this file. Click on extract all, and then you will get unzipped file where you will be having the images of dogs and cats. You can see there are a lot of images of dogs we have, lot of images of cats we have, and it's a quite huge data. So you can see almost 10,000 images are of cat, 10,000 images are of dog, and then in testing part, we have 2,500 images of dogs and 2,500 images of cats. So just get ready with this data before we will proceed ahead. Do it. I'm waiting. Then maybe we can move further. Just let me know whether this link is accessible and everyone is able to download this data. Yes, it is quite huge data. That's why I told you it is difficult for us to do the training in the live class itself. It's a approximate 1 GB of data. If you don't have a good internet connection, then things will be a bit difficult for you. Upload part, I will showcase you few ways to do that. That's not an issue. But for now, just try to have data with you. We will uh, discuss what we can do. What are the different options to tackle these huge amount of data? For unzipping part, to check, just click on this right click and click on this extract all. If you can click on this extract all button, you will be able to extract the entire images. Saurabh will discuss everything. What are the ways directly accessing it from Kaggle, directly accessing it from Google Drive, uploading it, all the ways I'll cover up in today's session. Because uh, when you are working with the real time data that will not be there in your Kaggle, right? Then how will you tackle that situation? We need to discuss that. Waiting for a few minutes. In the meantime, I am bringing my water back. Just do it and then we will start our project. Is it done? Shall we move ahead? It's okay. Take your time. extract here for now in your local system itself. In the meantime, I am opening the collab file. Are we ready? Yep. Are we ready to discuss further? I'm sharing you 3 links of my collab files. Just let me know whether you can access it or not. By the way, everything I will upload in the today's drive link as well. So don't need to worry. But for now, just for your reference, you can just check. If you want, you can open all of these files in your system as well. And then maybe we can move ahead. Chale? For now, if you won't be able to get your data ready, it's completely fine. As I told you, in the live session itself, it is difficult for us to implement because, as you have already seen, it's a very huge amount of data because it contains images. That's the only reason. Although it's not that we have too many files available, but it's just that whenever we are working with image specific data, in that specific case, automatically the size will get increased, especially if it's a RGB based image. That's the whole point, and because of which you will be able to see it is taking some time. And you can imagine if the downloading and extraction takes this much time, then how much time will it take to train the model. Why I have made you guys to share this data and have availability of this specific data in your local system, because what I will give you as a task for today is to implement all these three files on your own. And whenever we will meet next, you will have to tell me that whether you will be able to successfully run the files or not. uh, I have shared the three collab links because every collab link serves different purpose. That is why. So you should have all of these three links available with you. Uh, shall we start discussing all these files one by one and what these links are doing? What is the purpose of that? Everything we'll discuss. Shall we move ahead? Now, first of all, whenever you are starting any project, it's very important to have a in-depth picture of what our data looks like. So I hope everyone gets this much clarity that here in this specific part, we are trying to solve a problem of a classification task. How many number of classes we have over here? Two classes, either it will be dog or cat. So is that a multi-class classification problem or is that a binary class classification problem? Binary. So can we apply directly a VGGNet 16 algorithm on it to work and give us the results? If I'll not change anything. So you know it composed of two components, convolution and fully connected layers. Without touching upon anything, can we directly use the model and give the results to our final part? Is that possible? No. Why is that so? Why you guys are saying no? Because exactly, when we have seen the architecture of VGG16, in the last fully connected layers, there they were dealing with 1,000 classes. They were using the softmax activation function. So in the very first part, what we will do today is we will apply the concept of feature extraction. Now everyone knows what is the meaning of feature extraction. Can I assume now everyone knows what is the meaning of feature extraction? So what we will do in feature extraction in our implementation today, we will try to make sure that the first block, which is I'm calling it as a convolutional block of VGG16, that will be freezed with its weights. So I won't do any specific change over here because somehow this specific convolutional neural network will have the weights which are I can directly fetch from the pre-trained models. And these weights are nothing but helping me to detect the features. Or you can say extract the features. Extract the meaningful features. But as a user, as a developer, my problem statement is a bit different from what this specific model will do. Because my problem statement is of binary classification task. So what I will do, I have further the dense layers available with me. I have further the dense layers available with me. So what we will do, we will just take these dense layers as it is in terms of working with our own specific task. So what we will do, we will try to take the flattening part. Flattening part obviously will come from the previous portion with respect to the multiplication of the given values that we will be having. But over this specific part, we will be having hidden layer. In the output layer, we will make sure that we will use the sigmoid activation function with a number of classes as 2. So are we ready to implement the same thing? Logically, it is clear, right, everyone? Practically, now we have to see how can we do it. First of all, in this own task wala part, the data set that we will be having, just check how many number of training samples you have. In training part, we have the images of cat, we have the images of dogs. Then in testing part, again, we have the image of cat, we have the image of dog. Just let me know how many number of images you have in the training part per se for cat and for dog. Is it 10,000 or 20,000? 150? No, it should be more. Train may, if we will go towards cat, I can see 10,000 items in my laptop. So if you are seeing lesser than this, it means that maybe some download issue is there. You have to check it again. That is why it takes a lot of time and it's a very big file. So anyhow, 10,000 cats and 10,000 dogs. So basically you will be able to observe, we will be having in total 20,000 images available in my training set. In my test set, if you will go back and check, in your cats, it is 2,500. I think same ratio is for dogs as well. So you will be having 2,500 over here, 2,500 over here. So in total, you will find out that we will be having 5,000 images available with us. Okay? Correct? So always remember, the ratio is actually, this is very good ratio, where you will be having a bulk of training images and a bit lesser amount comparatively the testing images. So you will always have this test data available with you, which is a kind of, I would say, unseen data to verify that whether the classification, which our model we have already trained on, is doing really well or not. Is that okay? Now, we have already understood our data. Let's discuss. First of all, in deep learning, the issue is the data set. Now, we are working with a Colab. There are three ways to work with this kind of data. Three ways to work with huge amount of data in Colab. One way could be where you have data available with you in your Colab, in your local system. For example, just like the way you already have right now. You can go towards left side. Once your file will be connected, give it some time. You have an option to upload. When you upload, you can upload the entire, first of all, the test data of dogs, then the train, then for the both the folders, you will be having subfolders. Everything you will do manual upload, and that is a feasible thing. But if you will go with this specific generic approach, it will take a lot of time, right? And it's kind of a lot of manual process which you are doing. Second way is which is kind of a easier way, where you can directly download data from the Kaggle itself. So you just have to mention the path. It will simply download it, and it will be able to help you to access that specific data, whichever you will be having, right? Third way could be, which is I find it much better approach, is you will open your drive, whatever drive you want to work with. What you will do, you will just try to create a folder. For example, I'm saying deep learning project. In this deep learning project, you can just try to directly upload the folders. You will say folder upload. You can give the train folder. It will take some time and upload all the 20,000 files available with you. Then wait for some time, because at your end, at your home, you will be having definitely a lot of time. Then once this will be uploaded entirely, you can upload the entire folder in your test part as well in this project. This is a good practice, because sometimes when you directly fetch the data from the available website, it might be the case that after some point of time they have not they have changed their API, they have changed the path where the data is available, they have changed the URL link, because at that point of time the access is at their end. So the better idea is where you can try to download the data, upload it in your local drive, whatever be the drive where you are working with. And once the data will be uploaded, then start working on it. It might take some time. If you have a good internet connection, it will be done within, I would say, let's say maximum, I'm saying half an hour. And once the task will be over, then what you have to do is go towards again right side, sorry, left side of your screen. There is an option of mounting a drive. So you have to click on this specific option. After a few minutes, your drive will be connected with the Collab link. So once your drive will be connected, what will you able to get? So it will take some time. Let me just try to check. Okay. So they have given us a code. We need to run this code to give the access to the drive. And once you run this, click on continue. So somehow we are providing them the permission to retrieve the content. And once you will do it, it will take some time. And now if I'll refresh, you will be having this one folder available with you called as drive folder. I hope everyone can see. So few minutes back, I have made a folder deep learning project where I have a train data in which I am grabbing the links, right? So what you're supposed to do is your data is available with you for cats and dogs in the training path. You just have to copy the path. So how can you copy? Click on these three dots, copy the path, and whatever path you have, just have to paste that in the file wherever it is required. Similarly, you will be having a test folder also. You can work on the test folder upload, and then this will be available in your drive. So this is one of the, I would say, easiest way to work with the deep learning project, where whatever data you have that data in your local drive, connect or mount that drive with your collab, and then you will get the entire drive authentication. Once you will you will be able to give them the permission, they will be able to access your entire drive. After that, wherever your data is available, just click on three dots and copy the path and use this as a path to get access of the data points. Is this clear to everyone? Shall we move ahead now? Data problem is clear? Yes or no? Perfect. Now, in this specific case, there was initially the API of Kaggle, which is helping the users to get the access. But today, when I tried to run this specific part, it is somehow showcasing me an error. So that is where I was telling you that sometimes this kind of issue will arise, because open source documentation, open source APIs keep on changing, and it changes in a very rapid manner. So having a data available with you in the drive, it will always be available until or unless you won't delete it. So that is where your code will always be correct. So at your end, once this today's class will get over, you can just simply remove this Kaggle wala part, and the way I have showcased you, in which you have to upload the both the folders, and then whenever you want to access the data, you can directly copy the path in this specific file to get access. Please do like that, okay? So that in future you won't face that specific trouble. Anyhow, showcasing you this specific code, it's a way to unzip a file. So we have done the unzip part manually in our local system. Directly, if anyone wants to do, in a Python, we have a function called a zip file. It will unzip the file and store it in a specific location slash content, which is the collab location that we will be having. Now, this is where the actual code will come, where you will be able to see the step number one in this specific code is to import all the required libraries, just like the way we usually do, right? Once you import it, so you can see the kind of libraries which we were using from the past few days: TensorFlow, Keras, sequential, dense, flatten, VGG16, every specific model we are using over here. Now, I hope you all remember from where it is coming up. So in the last session, I have showcased the implementation. So this is where they have directly copied this code and they have pasted it over here. So weights are directly we are fetching from ImageNet database. There is one variable called as include underscore top, which we are saying it as a false. Anyone having any idea what is the meaning of this specific parameter? So this parameter is available in your, you will find it over here also. By default, it is true, but intentionally we are making it false. Whenever, listen it very carefully, in transfer learning, you will always make it false. Whenever you want that this top means this specific neural network wala part, this is the topmost portion in your neural network, in your, sorry, architecture. So what I want is I want to exclude this. I just want to use this convolutional base. I want to exclude this. So how can we implement this in deep learning? Just you have to use this parameter, include underscore top, just make it false. Once you make it false, it will just fetch that initial convolutional layer. It will not fetch your dense layer. Is it clear? By default, it is true. When it is true, it will take the entire structure. As soon as you will make it false, it will just take your convolutional base, nothing else. Give me the confirmation if it is clear or not. Then the input shape, if you will refer the, again, Kaggle link, you will also find it over here. Also, if you will try to check the properties of the pictures which you have in your local as well, you will be able to see that the image size is 150, 150. It's the input dimensions. And it's a RGB image, which we can clearly see it's a colored image. So, comma 3. So in this way, we will be able to make ourselves ready, our model ready with a convolutional freezed weights. So this is where we will be able to get the results. Make sense? So we have applied the model. We have used the weights, pre-trained weights. We have mentioned that the value of include underscore top is false because we just want the main convolutional layer. We don't want that specific, I would say, uh, what I would say, the dense layer part. So we have make it false, and the input shape value, which is 150, 150, 3. Yes, it only takes the weights, pre-trained weights from that image net, which basically helps us to detect the features. So what we are saying in this specific model, just give me that red or orange wala line. That's it. I don't want that green colored line. That's it. Now, if let's say you want to implement ResNet model, so you have to just change the model name. You want to implement any other specific model, let's say efficient net, let's say mobile net. What you're supposed to do is just go inside that. You will see everyone's input call and the parameters are almost same, trained on all that ImageNet data only, 1,000 classes only. So just have to change the model name and your work will be done. I'm using for now VGG16 because we already have covered up in detail. So with respect to whatever model name you will specify, it will take corresponding to that specific pre-trained parameters. Give me the confirmation if this is okay so that we can move ahead. Let's now, when you will say that, give me the summary of this convolutional base. So if you will try to compare this with the yesterday's work that we have done, it will be almost same. The only difference is because now our input dimensions will get changed. In the yesterday's work, what was the input dimensions? Do you remember? No, it was not 28. 28 was the dimensions of MNS data. In yesterday's work, when we tried to build the VGGNet architecture, what was the input shape? Everyone is saying different number. Can you see the below diagram? 224 cross 224 cross 3. Today it is 150 cross 150 cross 3. So depending upon that, your parameters definitely will get changed, and your values of output dimensions will definitely will get changed. That's the only difference. Otherwise, you can see we are just going till max pooling. We don't have any dense layer parameters over here. Why? Because we have made this false. That's the only reason. Will that be making sense to everyone? Is this clear to each and everyone over here? Now, what's next? Our first task is done. Our first task is done where we are trying to create a, in the step number 2, we are trying to extract the base convolutional part from VGG16 architecture. Okay? We will be able to extract it. Now, once it is done, anyone who can tell me what is the step number 3? Step number 3 is to create our own, I would say, customized, fully connected layers as per the given data set. So that is where we know we will be having a sequential model. We will first of all add our convolutional base, which we extracted from VGG16 pre-trained model. Then next task will be definitely to flatten it down. So once you will do the flattening task, it will become your input layer. After that, this will be the hidden layer, where you are saying that I want the 256 number of neurons and activation ReLU as the activation function over here. And I want output layer, which is again a dense layer we will be having, where the final result will be a single neuron, activation is sigmoid. Why single neuron? Because we just are dealing with a binary classification task where the either answer will be 0 or 1, meaning that whether it belongs to cat or it belongs to dog. So once you will do that, you will be able to get this summary of your model, where you will be having VGG16 model, these many parameters, flattening layer, this is the parameter, dense layer, this is the parameter, then we have output layer 257. How we are getting these numbers? If you don't know, please refer my previous sessions. I already have conveyed this, that how these parameters, output shape, we are able to get over here. Is this clear? Any doubt till so far? Before we will move ahead. Shall we move further? So our somehow model is ready now, end to end. We have a convolutional base layer. We have our fully connected layer, which is specially designed to do our task. Are we ready with the model? Now, what is the next step we have to do? That is where now we will try to do a step number, I would say 4. Step number 4, where we will try to do the training of the model as per our own training set. That's the next task where we have to now start our training part. Now, there is one parameter which you will see. Convolutional underscore base dot trainable is equals to false. What is the meaning of this? Any guesses? Anyone? This is a very important parameter, which is specially used only in the concept of transfer learning. Listen this very, very carefully. We are saying this is the convolutional base. I hope you all know what is convolutional base. This is the convolutional base. Dot trainable is equal to false. What this parameter is doing? This specific parameter is saying to my model that please don't update the weights. So somehow it freezes the, if you want to do this task, by default it is true. So it freezes the model's weights, preventing, because now we have to start our training process. So you all know randomly weights will be initialized, backward propagation will happen, lot many things will happen internally. But what I want is that convolutional base will have the weights fixed. That's why we're using this pre-trained model. So you have to make sure that you will say dot trainable is equal to false, so that your main convolutional base will have the same weights, because here we are doing feature extraction. We are not doing fine tuning for now. We are doing feature extraction. So we are saying here that it freezes the model weight. It simply preventing them from being updated during the training process. All good? So you have to always make sure whenever you are starting your training process, you will have to make sure in the transfer learning part, in feature extraction, I have to freeze my weights. By default, this parameter is true. So if you will not mention it as false, it will internally change your pre-trained model weights as well, which is not the objective we want to do. Is this clear? Shall we move ahead? Now, we will be having a trainable data. We will be having a validation data, testing data. In the trainable data, we will again pass wherever data is available. Now here again in the directory, we will be passing the path when the train and test folder is directly available in the collab file itself. For you, the path will get changed because you are uploading it from the drive. So what you have to mention is, for example, you will copy this path, and I'm just writing in the comment. You can do it at your end at home. You will say directory is equal to, and here you will pass this path. Instead of passing the below path, your path will get changed because now you have already connected your drive. So this is the path. You will just have to copy and paste. Copy the path. Similarly, once you upload, for example, a folder upload, once you upload the testing wala folder as well, you will definitely get the test folder available with you. Again, see, test folder is available. If I will try to refresh it a bit, so within few minutes, you will be able to see it will be reflected over here as well. It is taking some time, but you will be able to get a proper folder available over here for test as well. Not this one, where it goes. Yep. Can you see a test folder is available? Just copy the path, and in the directory of your testing wala part, that validation set, what you have to do, just pass this specific parameter. Getting my point? Is it clear? So if directly the train and test folder is available in your collab, you can use this path. If you are connecting with your drive, this will become your new path. Now labels is you want to infer, which is of integer type. So basically we are dealing with a classification problem where we are indicating the cat as 0 and dog as 1. So that is why we are saying it's of integer type. Now batch size, I hope everyone knows, because it's a quite huge amount of data. So at the time of training, I am passing in the form of batches. So in one batch, I am passing 32 images. And what is the size of the image? It is 150, 150. Let me know, is this training underscore DS and validation underscore DS clear to everyone? Any doubt till so far? Labels is equal to inferred meaning. So this is again a method which you will be able to see in the Keras utils. It simply automatically assign the label based on the folder names in the directory. So let me write it over here. Label equal to inferred, automatically infer, automatically infer or assign the labels based on the count of the folders in the directory. So basically, let's say you have cat and dog. So I'm not doing it manually. I'm not saying that cat is 0 or dog is 1. It will automatically check in the train folder how many number of folders we have, subfolders we have. It will check we have 2. We have for cat, we have for dog. So it will automatically infer and assign the integer value to them, which is 0 and 1. That is the purpose of labels equals to infer. If you won't write it, then it will not do the automatic task. That's the whole point. If let's say you have 3 subfolders, it will do the inferring as 0, 1, 2, and so on. Now, once this is done, we are ready. Next task is to normalize the images. I hope you all remember, we already have covered up in our MNS data as well. So that is where you will be able to see how can we normalize. We can try to make sure that every image pixel value should be in the range from 0 to 1. So whatever image we are getting, we are trying to divide it by 255 and converting their pixel values in the form of float 32. Once it is done, we will be having the final image, we will be having the label. So this is the kind of a pre-processing task which we are doing. And finally, whatever be the images we will be having in train DS and validation DS, we are simply mapping it with the processed image. So what will happen? Whatever be the images that you will be having in the training part and testing set part, every image is now, before coming to the training DS and validation DS, will be pre-processed and all the values will be normalized to 0 to 1. The main reason to do this is because we know internally computation will be very, very heavy. So if you will try to normalize the images in the form of 0 to 1, that will be highly beneficial to reduce the computationally expensive task. That's the whole point. Batch wala part, batch size indicates when you are doing a training, in one epoch, how many number of images you want to pass. In one specific part, how many number of images you want. So what will happen is 32 images simultaneously will go and run and do the training part. We cannot do one by one because the image count is quite huge. That's the main reason. Is it clear, Pawan? This is where we indicate batch size. You can mention 32, 42, 52, 62, 72, whatever number you want, depending upon how much resources you have, how much time you have to train the model, right? Now, this is where our training will start. Currently, epochs is 10. You can make it 100 at your end. And I will also explain you, maybe not today, early stopping process, which I was talking about. How can we implement that so that you can make the epochs value quite huge and automatically it will stop wherever it will feel that there is a issue of overfitting. Okay? So we will discuss that part, maybe not today, but first of all, let's complete this transfer learning concept. But this is how training will happen. And then via matplotlib, you can plot the accuracy and the validation accuracy. So we can plot the training accuracy, we can plot the testing accuracy. Now here is one thing which you should observe. In terms of accuracy, in the terms of training accuracy, you can see I am getting maximum 98.33. So this red line indicate a training accuracy. In terms of validation accuracy, you can see uh, it went to the peak, which is, I think, 91.28%. It went to the peak. After that, it falls, and now it is having a lower value of 90.82. So what is the issue over here? Any guesses? Overfitting. Is there any effect of accuracy in the number of epochs? Definitely. Yesterday only we have covered up in depth towards the concept of overfitting. When you trained too much, which is not even required, when your epoch count is too much, then the issue of overfitting might happen. Have we covered up this concept yesterday? Yes. And this is a very best example of what is overfitting. At the time of training, you can see my peak is going up in the red color. But at the time of testing, so majorly what I'm trying to convey over here in this specific chart, if I'll just try to showcase you, let me open the pen. Give me some time. Okay. So if you will carefully observe this chart, this is the point where actually my training should stop. Because this is the point where my testing accuracy is a bit high. After that, it simply drops, increase, drop, increase, drop. No, it's not reliable. You're getting a training accuracy is 98, validation is 90. This is not a reliable thing. This is an example of what I call it as overfitting. Now, if you remember yesterday, I told you it might be the case that your model is still having a lower number of images, right? Because it's just 10,000 images of cat and dog, which they will be having at the time of training. So maybe we can try to feed more images, first of all, to check that whether this issue is getting resolved or not. And that is where, do you remember any technique to avoid this overfitting in deep learning? I have covered up one technique, augmentation, correct. So today I will showcase you practically how can we implement that. Yesterday I have showcased you the internal intuition behind the same. We will see the practical implementation today. But anyhow, this is the loss plotting, which you can see again. My training loss is going decreasing part, and my validation loss, it went to a decrease and then it again starts increasing. So this is the point where usually the training should get stopped, because after that the loss is just keep on increasing. Loss means the error which we are talking about. So this is a simple idea about how can we apply feature extraction transfer learning part. Is this clear to everyone before we will move ahead towards the resolving part of overfitting now to the next file? That is why I have 3 files available with me today. And that is why I'm not implementing it side by side, because if I'll implement, I won't be able to showcase you everything. We will stuck in this specific point itself. And our session will be very long in that case. But by saying that, please try to implement everything at your end, at your home. I'm expecting that you will do that. Yes or no? Right? I'm sharing you everything. I'm explaining you in a way, one line of code, bit by bit, so that you should know what you are doing. Still, if you have any doubt, maybe in the upcoming session, you can first of all discuss with me that point before we will move further. I am also stopping at this specific thing. You can do at your end, but if I will do it, it is of no use because I don't want to implement it again. I already have done it before this session. Okay? Now, let's try to work ahead and see that how can we apply the improvised version of the same. So everything will remain same. Here we are importing the libraries. We will be having VGG16 with us. Model is ready. Trainable parameter is false. This is where the difference will lie. This is what you have to understand. Data augmentation. So what is data augmentation? Do you remember the definition? What is data augmentation in deep learning? We will discuss the implementation of dropout as well, Shivam. We will discuss, don't worry. Step by step, whatever maximum I can cover up in the implementation in my classes, I will definitely try to cover up. If still there is something which will left, please try to explore on your own as well, because multiple concepts now you already know, right? Implementation, you can get it. Early stopping, dropout, but I already have planned. I will cover up in the, like in every project, whatever we will do in our classes, live classes, we will try to cover up different techniques. For example, today you are learning data augmentation as a new technique. In the upcoming class, whenever the overfitting part will come, we will learn regularization as the new technique. implementation of that. In upcoming part, maybe we will learn dropout as a new technique, right? So data augmentation is nothing, but we already have discussed what we are doing over here. In order to expand a data set by applying, you can say, random transformations. When I'm saying random transformations, I'm talking about rotations, I'm talking about flipping, I'm talking about scaling, etc., to the existing images that we will be having. Okay? So what we will do, we will try to import a image data generator, array to image to array, load imager. So all of these things will be utilized over here. So basically what we are doing, batch size we are defining as 32. Now in the training set data, we are trying to do a rescaling, shear range, zoom range, horizontal flip. All of these are the parameters in the image data generator, which will basically help my data to do data augmentation task. So if you will try and go towards image data generator and will check the parameters inside this, you will get the understanding of each and every parameter what we are doing. There are so many, if you can see. So here, if you will be able to observe, what I want to showcase you is not this one. So you can see over here that these are the parameters that we will be having: feature-wise center, feature-wise standard normalization, whitening, epsilon, rotation range, width shift range, height shift range, horizontal flip, vertical flip. So one thing which you will be able to observe in all of these parameters, everything is by default false. Now, all of these things, whatever parameters we will be having, this is actually helping to rotate our data in a way that we will be able to get a new feature out of it. Now, these parameters comes from the motivation of mathematical intuition, mathematical part, with respect to what specific pattern of image you want at the end of the day. So that is where few of the parameters we have made it. For example, rescaling we required. After that, shear range, zoom range. Anyone having any idea? I think this is quite intuitional. What is the meaning of shear range and zoom range? Anyone? Zoom range? Any idea? You must be able to see these kind of features in your maybe mobile phone as well. Shear range simply tries to shift your image more horizontally or vertically. Kind of it creates a skewed effect. ठीक है? Zoom range is how much zoomed in or zoomed out you want, right? It zooms the specific image that we will be having. Horizontal flip, whether you want, or vertical flip you want. So basically that is what we are doing. And after that, for the testing part, we are trying to rescaling it to 1 by 255 again. And then we are passing again train data generator and validation data generator. Inside that, similar thing, the path, the target size, the batch size, and the class mode. Again, it's binary because it's a binary classification problem. So you will be able to see 20,000 images are available in the training set, 5,000 images are available in the testing set. We are compiling it, we are trying to fitting it, and then the only difference that we have made is this specific path where we are trying to do the data augmentation. And the difference which you will be able to see by doing this is we will be able to get training accuracy as 92.86, validation accuracy as 91.48. Does it improve overfitting? Does it improve overfitting? Yes. Why I'm saying yes? Because now if you will try to see closely these values, somehow our training accuracy and the validation accuracy is quite similar. There is not a huge difference between these numbers. And that is where we will call it as a best model, because it's not about, you can ask me that Priya previously in the training part when you were showcasing to us, it's 98. Now it is 92. So it should be bad, right? It should not be a good model. We can improvise on top of this. I'm not saying that this is the world's best model. I'm not saying this. Maybe when we will try to make the epoch maybe 100, it might be the case that by increasing the epochs, it will be able to train it well. It's just for demonstration purpose, we have done it 10. But the point is, you always have to make sure, don't go only with numbers. What I have observed, people just check the training accuracy, and if it is good, they're very happy. Try to compare your accuracy with the validation accuracy. Even though if you will be having a lesser training accuracy, but your validation accuracy is also lesser, it means that you're going on the right path. But if let's say you are saying my training accuracy is really awesome, but as soon as I'll check my validation one, it's very less, then it means your whole model is wrong. In this case, I won't say that my model is wrong. I can say that maybe I have to increase my epochs to train it more prettier well manner. But at least whatever be the learning it happened in a very much apt manner. That's the whole idea. So if you will see the again the graph of accuracy and validation accuracy, now it will make more sense to you with respect to the graph of accuracy and the loss, which you can clearly observe over here. Making sense to everyone? Is this clear? How data augmentation might be useful at the time of overfitting? This technique is clear to everyone? Everything is same what we have covered up in previous discussion. Only difference is that block. If that concept is clear, everything should be clear to you. I have just simply copy pasted the previous blocks. I have not done any changes. The only thing is this one. And whenever you want to apply data augmentation at your and in your project, you just have to copy this specific code block, and you can apply at any point of time in any of the dataset that you're working with. So this is the overall discussion about feature extraction. So in both the cases, in the previous file also, and in this file also, we have done feature extraction only, because somehow, if you remember, in this file also, we have freezed our weights. Yes or no? By making this parameter as false. So in both the cases, transfer learning is applied. In both the cases, we have freeze the weights. So we will call it as a feature extraction part. The only changes that we have made is in the dense layer portion. That is why it is called as transfer learning feature extraction piece. If train and validation is reliable accuracy, what about test with train? I didn't get your question, Shivam. First of all, you have to check the training part, then the validation part. What I'm saying is, whenever you're checking the accuracy of training and validation, it should almost be similar to each other. There should not be a huge gap. If there is a huge gap in a way that training is having a very good number, testing is having a very bad number, then it's a overfitting. If you are saying vice versa case, it will never ever happen in the history. Because if you are saying that training is bad, but my testing accuracy is very good, will that happen at any point of time? Not at all. If your training is bad, accuracy is very bad, how the testing will happen great? So vice versa case won't happen ever, if you will think logically. Is this answers your question, or the question is something different? If it is different, you can clarify. Otherwise, we can move ahead to the next part. Yes, if training accuracy is low, this will be a overfitting. Shivam, you can maybe unmute yourself and ask your question. I'm really not getting your question. Let me give you a permission and then you can ask. Go ahead.
Yes, ma'am. All the thing we are seeing here on validation data. Um, what about the test data?
This is test data only. So what we are considering over here in this specific session, the testing data, validation data, they both are same for our task, currently what we have done and previously also what we have done. Usually when we will work, we usually try to split the data into three components: training, testing, and validation. That is where the difference between testing and validation will come into picture. That portion I have not covered up till so far. So here we are considering, we are having assumption, validation, testing, both are same. Is it clear? Shivam? Is it clear? So here we are considering validation data as test data only. For now, don't get confused between validation versus testing data. We will cover up that concept later on, that like you can do a project with only this two splits as well, but what will happen if three splits we want to do, and at what point of time we should do three splits, I will talk about that when we will discuss about hyperparameter tuning. At that point of time we will discuss those topics. Okay. Let's move ahead towards the last important point, last important discussion of today's class, which is about fine tuning. Now, you all know what is the meaning of fine tuning, that here somehow we will be working with the blockage of the convolutional layer as well and dense layer as well, because let's say we are working with the entire different problem. So we will import the files, VGG16 we are trying to extract, everything will remain same. This is where the difference lies when you will be working with a fine tuning based problem. Do you remember this parameter, convolutional underscore based or trainable? When we were doing the feature extraction part, this parameter was false, which somehow helping me to understand that, hey, you have to make sure that this specific value should be freezed. Yes or no? Do you remember that? Now, what we are doing over here, we are saying make it true. What is the meaning of this? We are saying update the weights at the time of training. Now, if I'm saying update the weights at the time of training, do I want to update the weights for the entire convolutional base? No. Maybe I want to use the initial few blocks and previous one I just want make it false only. So for doing that, what we will do, we will use one parameter called as, or variable called as set underscore trainable, which will be initially false. We are in a convolutional base, the layers are defined, and this specific layer, the last layer, internally it is called as block 5. The name of this layer is called as block 5. This is block 1, this is block 2, block 3, block 4. Let's assume I want the block 5 only to be true, remaining ones should be false, because I don't want the remaining 4 blocks to update the weight. I just want block 5 should update the weight. Are you getting my point? What is the meaning of block? Layers, what we are calling as layers, they're calling as block. Internally, by default, it's already been defined in the VGG16 architecture. So what we are doing over here is we are simply applying a for loop, which will extract layer by layer everything. We are just checking that whenever the layer name will become block 5 underscore convol, in that case, just make this parameter set underscore trainable as true, right? Otherwise, make it false. So if you will be having a layer name as this, set this as true. If this is true, make the trainable value as true. Otherwise, make the trainable value as false. So what this specific task will do, you can see below. For the initial blocks till block number 4, our trainable parameter is having a value as false, which helps me to make sure that the weights should be freezed. And as soon as I'm reaching towards the block number 5, which is composed of 3 convolutional layers and 1 pooling layer, that will be marked as true. So in this specific manner, if let's say you want to stop, you want to make sure that block 4 and block 5 should be true, in that case, just have to apply one more if condition where you can say block 4 underscore con 1 and block 5 underscore con 1. I want both of them to be true. Remaining should be false. So you have to make sure that whatever specific parameters you want to make it true, you have to make sure that trainable parameter should have that value as true. Remaining should be false. Wherever there is a false, it means that these weights are fixed. Wherever this is true, it means that at the time of training, these weights will get updated. This is the important point in fine tuning. Is this clear to everyone? This is the important, I would say, difference between the previous portion that we have covered up and this specific fine tuning portion which we are covering up right away. Is this clear or shall I explain it again? Clear to everyone? Simple for loop we are applying. If you know how the looping works, you will be easily able to understand this concept. Now, once this is done, we have a summary. Now, if you will be able to see in this specific summary, somehow our trainable parameters are till this point. And after that, no changes are happening. We are not doing anything, right? Because block 5 is false, is true, sorry. So now we will again create a sequential layer. Everything will remain same. We are trying to use the training data set, validation data set, processing the image, again compiling the model. Everything will remain the same. So whatever file you have understood at the very first part, same block I have copied. The only difference is the above thing, where I have just made one block trainable parameter as false, sorry, as true, remaining are false, so that whenever I am starting my training process, that specific values should be updated. So now my training will start. And here you can see the results. We will be having accuracy 99.89. By the way, in this fine tuning, I have not used data augmentation. If you want, you can use it. That will always help you to generate a better result. Because again, here you can see there is a difference. Although the difference is not that much huge, but still, I think if you will try to work on it, maybe by increasing the epochs and applying more images via data augmentation in the fine tuning part as well, you will be able to get a better accuracy. So here you will be able to get the results. You can again plot it, just same thing, accuracy, validation, accuracy, loss, validation, loss. And that's the whole point. So the crux of this file is this specific portion where we are trying to solve the fine tuning problem. And that's where the complete discussion of transfer learning is completed now.